morning, everyone. As usual, any questions? Okay, we do number 43. So the main thing basically we need to memorize from this section is the volume of a shell. Once we know the volume of a shell, we are good to go. So we look at 43. All right. So we have the region which is bounded by. Oh, whatever. So it's the region bounded by the graph of y equal x squared, x equal 1, and y equal 0. So it's a very basic region. So we don't need this piece. Okay. And we're going to rotate this around y equal -2. That's the axis of rotation, okay? And the question is, use the shell method. So I want you to practice the shell method in this problem. All right. So the shell method, it means that we have to take slices. First, this is equal to 1. This is the graph y equal x squared. So this point right here has to be 1, 1, okay? So the shell method means we have to take slices which are parallel to the axis of rotation. So these are my slices. Okay. And we're going to rotate a typical slice. So this slice, when I rotate it, it's going to generate a shell, big shell right there. That's what's going to generate. And the center of the shell is right here on this line. Okay. And this is the line y equal -2. Okay. So this is my yi here because I'm taking horizontal slices. So my y is the variable, and this is the point 1 right there. Okay. So now typically we have to find the volume of the shell, and then we're done actually. So volume of a typical shell. We need the radius. We need the height and the thickness. Okay. The radius goes from where to where? The radius is from your slice basically to the center of the shell, right there. That's my radius. So it's equal to what? So on the picture is from here to here. So quickly, what's the radius?
yi plus 2.
Yeah.
Right, it's yi basically plus 2. Or yi minus -2, upper minus lower. So that's my radius. And honestly, we are done. What's the height? The height is from here to here. How much do we have from here to here? Again, look at the picture.
Won't that be x squared?
No, be careful.
It's the square root of y.
Oh, yeah, yeah.
yi is my variable. yi is the variable. And I need from here to here. I give you a minute to figure this out.
It'd be 1 minus square root of y.
Right, it's going to be 1, the right curve, minus the left curve. 1, the right, minus the left. It's the same principle all the time. So if this is yi, it means this point here is actually the square root of yi. So we have to solve. So y equal x squared. Give me x equal the square root of y. So if this is yi, from here to here, I have square root of yi. This is 1. So the height is going to be 1 minus the square root of yi. So this here is 1 minus the square root of yi. And finally, my thickness is the little delta y. Okay, draw the picture. I repeat, really, once you understand, you take the picture, you label it well, you're good to go. Okay, and always remember, if we are taking horizontal, y is my variable. Everything has to be expressed in terms of y. So now we are actually done. Volume of a shell, of a typical shell, is almost equal. Basically, what we're doing is 2 pi times the radius times the height times the thickness. So it means that it's equal to 2 pi yi plus 2, 1 minus the square root of yi, and delta y. So my whole volume is going to be the integral of, so it means we're adding the little volumes. So that's transform it into an integral. And then as usual, we go back to the picture and ask ourselves which interval we have to divide into pieces to cover the whole region. And we have to divide the interval from 0 to 1. So to cover the region, we have to go from 0 to 1. And the rest, I will not do it because it should be simple. You just distribute and you are done. Okay. Any questions about this problem?
Can you go up a little bit to the top? Thank you.
That's the shell method, right?
What?
That's the shell method, right?
Shell. Yeah. Yeah. You just think when you're rotating, what you're getting. Remember, the washer, the height is tiny. That's really the washer. The height is the delta y in the washer. This is the height, is the distance from here to here. That's the height. And the delta y is the thickness of the washer here. Sorry, the thickness of the cell. That's the shell. In the shell, this is the height. In the washer, the height is this little delta y. And the delta y, what?
I have a question.
Yes.
How do we get the, I think we talked about this obviously in the last meeting, like the last quiz. How do we get the volume? I don't know if we'll be asked this or not, but like the volume of a typical washer or disc. Would that just be,
Repeat your question. I'm not really getting it. Sorry.
would we have to be asked the, because would we have to be asked the volume of like a typical washer or anything like that? I think we did on the last quiz.
Yeah. The questions will be basically what I'm doing here. You draw the picture, you label it very well. Volume of a typical washer, then to set up the integral.
Okay, and then the volume of a typical washer would just be what, pi r squared?
No, you should, I mean, this is, you
or
should,
the
it's
radius.
pi times the outer radius square
Yeah,
minus the inner radius square times the little height, which is usually either delta x or the delta y.
okay.
Okay.
And then like conceptually, when you're actually taking the integral, the delta x is becoming,
The x.
okay,
Delta x become the x, delta y become the dy.
okay, cool. All right.
So let's look at the others quickly if we can. Let's see, 35 should be along the same line. And what is it about? So we have y equal x. Y equal x. And y equal x to the power a third. X to the power a third go like this. So that's really my graph. Sorry. So this is x to the power a third. And this is y equal to x. And in the first quadrant, about the x-axis. And the question is, use both the shell and the washer. Okay. So we will do 35. We will not do and we're going to rotate around which one, the x-axis. And this one, they want me to practice both methods. the washer and the shell, just to contrast them. So we're gonna do the shell first. And then I do the washer here. The shell. I'm rotating around the x-axis. How should be the shells? Quickly. So the typical rectangle, horizontal, horizontal, because they are parallel. So what's my variable quickly? Y or X? What's my variable?
Why?
Y.
Y.
Why?
That's sweet. And probably at this stage, the problem. So now we're gonna rotate this. This is my shell right here. This is my center of rotation. That's the center. So my radius for the shell has to go from here, the edge, all the way to the center of rotation. Means this is my radius from here to here. So my radius is simply yi. And my height. I give you a minute to figure out my height.
X minus X to the power 1/3. Oh wait, no, we have to change.
Why I am
Y minus
big.
Y/3.
right. This is the height from here to here. It's a horizontal distance. Yi is what I know. You don't know X, you don't know Yi. You want this horizontal distance. So it's going to be the left curve, sorry, the right curve minus the left curve. It's not inner and outer, it's the height. So the height is going to be the left curve, y equal to x. And here, I need to solve for x. X will become y to the power 3. So the height is going to be basically the x of the right curve minus the x of the left curve. Okay? Y is your variable, everything in terms of y. So how much do we have here? So basically, I don't want to put, I'm afraid to confuse you here with the shell method. So this is yi cube, and this is here is your 1. And that's what you want. That's really your height. That's your height. That's your height. And the thickness is delta y. Delta y, okay? So volume of a typical shell. So typical is 2 pi times the radius times the delta I. And the total volume is just 2 pi y, y minus y cube, the dy. And my integral go from 0 to 1. Because those intersect at 1, 1, if you do the math. Okay. Washer. What kind of slices we have to take for the washer? So we're rotating around the x-axis, so I'm definitely have to have enough. Yeah, I have to have another picture. So we have this, and you have this line. That's my axis of rotation. Now I have to take those slices. This is my slice. Okay, so this is my delta x here. And this is, I'm gonna rotate. I'm gonna have this big hole in here. So you can see it's very, very different from the washer, very different. That's really from the shell. That's really my washer right there. And to find the volume of the washer, I need the inner, I need the outer, and I need the height. And so, sorry, I forgot, this is my xi down here. So that's xi. So my inner is equal to what? Very quickly.
Just x1/2.
No, the inner. It's from
Oh,
here.
I'm sorry.
That's okay.
It would be just x.
It will be xi itself. If this is xi, from here to here, I have xi because that's the
Why? Because you have to switch in terms of y.
What? No, what's the variable here? Which interval I'm dividing? The interval on the x or the y axis? If I am covering with vertical rectangle, it means xi is my variable here. X is my variable, sorry. Because I'm dividing the interval on the x-axis, not the interval on the y-axis. So x is the one that varies. I'm doing rotating this plus this plus this, but every time x is my variable, not y in this case. And my outer is from here all the way down to here. That's my outer radius. So my outer radius is, if this is xi, from here to here till I hit the curve, that's a vertical distance. That's the xi to the power, that's it to the power a third. So my outer is xi to the power a third. My height is the little delta x. So now finally, volume of a washer. So volume of this little piece here is equal to pi times, that's the height, the outer radius squared minus the inner radius squared. The outer is xi to the power a third. The inner is xi. So finally, the total volume is the integral. All those problems happen to be 0 and to 1. So this will not to be the case on a lot of problems, of pi times x to the power a third squared minus x squared dy. So I will write it here. So usually I get you ready for the integration and then I will stop at this stage. So that's the integral from 0 to 1 of
Why would it be
x.
dy?
Oh, because to make sure you guys are listening very well.
Oh,
Okay, so this is the x. So now you're doing well. X a third to the power 2. That's what my calculus teacher used to tell us whenever he does a mistake. Minus x squared dx. Okay, and the rest should be a simple integral. So, okay, and I'll have a look at 24 and see if it is hard, easy, what it is. Okay, I'll set up 24. Done, guys? So 24 is just, we have the curve. This is the curve, y equal 0, x equal to 0. So I am in the first quadrant and we're gonna rotate about y-axis. And do they specify the method here? Yeah, they seem to want us to practice the shell method. Okay, so this is my function. It's the first quadrant, so we're gonna draw it first. This is one day you will recognize this is basically an ellipse. And if x equal to 0, I'm right here. So it's gonna look something like that. I'm gonna rotate it around the y-axis. Okay, so I want the shell method. It means parallel to the axis of rotation. It means they are vertical. Xi is my variable. So that's the picture. So that's the basic one. All right. So I need the radius. I need the height. And finally, the thickness. Okay. The radius is from here to here. That's my radius. My height is from here to here, which is the square root of that. My thickness is from here to here. Okay. Now, volume of a shell is 2 pi xi square root of this delta x. Now I'm not put the integral. All right. I need the limit. So which interval I need to divide? From here all the way to here. So that's the one I'm going to cover with rectangle. What's the value here? What's happening here? Here, what's the value here? To find this value, I need to set the y equal to 0. That's what's happening here. The y of the curve is 0. So it means 2 minus 4x squared equal to 0 means 4x squared equal to 2. X squared is a half. X is plus or minus the square root of a half. So this right here will have to be the square root of 1/2. Okay, so this time the limit, thankfully, is not a 1. So that's the integral from 0 to the square root of 1/2 of 2 pi x square root of 2 minus 4x squared dx. And yeah, what?
I know you bring these different methods in for specific cases, but do they work for any graph?
Yeah.
Okay.
Yeah. Okay. How do we find the entire derivative here? Quickly. Usually I stop when I know that usually we can find the entire derivative.
Using substitution.
Absolutely. Use substitution. There is no way out. This is my inside, and the derivative is almost looking at us. So there is this use substitution in this case. So that's 2 minus 4x squared. And this will give me the du is minus 8x dx. So now we are done. This is equal to 2 pi. The x dx is minus 1 over 8 du. That's the dx. So x dx give me the minus 1 over 8 square root of u du. And now I want to change my limit of integration. So I change limit. Change limit. If x equal to 0, my u is equal to 2. So that will become a 2 in here. And if x equal the square root of 1/2, my u become 2 minus 4. X squared, it means square root of 1/2 squared, it means it's a half, which is equal to 0. Now I have a very simple integral in u. With the new limit, which are basically fairly simple, then I will have minus 1 over 4 pi antiderivative.
I have a question.
I'm stopping, yes.
Where does the x go? From right there, from 2 pi x.
I don't,
From the original volume equation.
yeah, this is the xi, right?
Yeah, I'm
Here.
saying, where does it go in the substitution?
Right there. Ah, here you mean from here to here?
Yeah.
Okay, what did I put u to be? This
Oh,
inside,
Yeah.
right? What's the du? What's the derivative?
Negative 8x dx.
Very good. X dx is minus
Oh.
1. Okay? X dx is the one minus 1 over 8 du. Okay?
All right. Thank you.
Got it? Okay, somebody else tells me, wouldn't the upper limit be 2? This one, Roja? This one? Tell me yes or no. Okay.
He means the one below, the square root of u, right under. The
this
2 is
one?
on the lower one. Yeah, and the 0 is on the upper.
No, no, no. If x is 0, I plug it back in here. What this will give me for u? It
2.
gives me 2. Exactly. It stays where it is. I'm not changing anything.
Doesn't it give you -2 though? Because if you plug in
No,
0
no,
for
put
oh
x
no
in-
no no yeah you're right
Yeah,
sorry.
yeah. No, you don't change anything. If this for x0, u is 2, you put u where it belongs. If x is the square root of 1/2, what's the u? 2 minus 4 times the square root of 1/2 squares give me a half. Then I have 2 minus 2, which will give me a 0. So this turned into the 2, the upper one turned into a 0. William, did you make sense to understand? Or anybody else? I know I cannot change, not because this is smaller, sorry, this is larger, I have to put it up here. No, whatever the value of x here, what's the u that correspond to this value of x, I put it lower, and exactly that. I don't really play at all. So this is gonna give me 2/3.
So you got the new integral from plugging the
Yes,
original a and b values into u.
yes.
And then
yes.
how did you get the -1/8 again?
What's the derivative here? What's the du?
Oh, that would be -8x.
Got it?
Okay.
Got it?
Think
Clearly?
so, yeah.
So you find the derivative. What's the derivative? It's minus 8x dx. That's the derivative. So
Okay.
basically, the derivative is du dx is minus 8x. So the du is minus 8x dx. With me?
Oh, okay. So that's just from the.
Substitution.
Okay. Got it.
So finally, this is from 2 to 0. And it's going to give me equal to. The 2/3 could be factored out. And then I will have 0 to the power 3/2 minus 2 to the power 3/2. And then minus minus is a plus. Of course, we have a plus. We're finding volume. If I get a negative answer, it means I am definitely goofing. And then I will have 2 times this. I will have pi over 2 times 2 to the power 3/2. And of the problem. Okay. So here goes my lecture for today. Yeah, guys, just to remind you that next Friday will be your first exam. Probably some of you know that, probably not. So I will put the review tomorrow morning, hopefully. I will have a review for you out there, okay? And everything I do next week, everything will be absolutely on your exam, all right? So whatever we do next week, it will be on your exam. Any questions before we let you go? Because the quiz open at 8:30, not 8:28, but I don't have time to
Yes.
start the new lecture. Any questions?
If you don't know the graph of the square root of 2 minus 4x squared, is there a good way about like figuring out what it would look like roughly?
Are you talking to me?
Yeah.
What is it? What's your question?
So when you're trying to give an estimate of the graph of it's like when we were doing the square root of 2 minus 4x squared, that is our graph. Like, I wasn't sure how that looked on the graph. Is there a good way to figure it out?
In your case, you use your calculator for it.
Okay.
Okay, in your case, you can use your calculator. Okay, and this is basically an ellipse, and I tell you why it is an ellipse. If you guys, I don't know if you remember the equation of the ellipse. It's x squared plus y squared over b squared. You guys remember this equation? Maybe not. So when I have the square root of this, I square both sides, I will get that.
Oh, okay.
equal to 2. Am I right?
That makes sense.
Because this will give me this. So y squared, this is really an equation of an ellipse, because when I divide across by a 2, basically I would get something like that. This divided by 2 would give me equal to 1, but this one give me 2x squared. And then if we do a little bit more math, and this is something we will review at the end of the course, so we will not let it go, equal 1. And that's a typical ellipse. That's a typical ellipse. So that's how I know. So this graph basically should have been like this. That's the kind of a graph. That's a total ellipse. And what they want is they want only the piece in the first quadrant. So they only wanted that piece. All right. So that's how I figure out that's an ellipse. I don't memorize all the graph, but this is one of the basic one that we actually eventually we should know. Right? Any other questions? Okay, the quiz right now is open. Get going, please. Just a note, you will be very much, I will put a lot of grade on labeling your graph correctly, whatever method you use. So if you use the washer, I want the inner, the outer well labeled. If you use the shell, I want the radius and the height. So labeling is important. Volume of a typical washer or shell should be clear, and then the volume. And you do not have to evaluate. Don't worry about evaluation on this quiz. Please put your camera on. Sorry to disturb you. Please put your camera on.